All right, so continuing discussing domain and range. Domain, if you remember domain from a little bit ago, domain is all the things that we can input into the function, and range is what comes out. So this is section 21.b, and so the question is, we are looking for the domain of these functions. So example 21.4, we have f of x equals the square root of 10 minus x. And so the question is, what are we allowed to input into this function? There are two things that you have to bear in mind when you're trying to find the domain of a function. And this should probably be written down on your formula sheet somewhere. There are two things you can't do. You can't divide by zero. Can't divide by zero. And secondly, you can't take the square root of a negative. Now, I know that you're advanced enough that you know about imaginary numbers, but that idea does not apply to functions here because we are only interested in real numbers, as you'll see in just a second. So, these are the two things to watch out for in the domain, regarding the domain, or restrictions on the domain. You can't divide by zero, and you can't take the square root of a negative. Well, example 21.4, we have our function, which is the square root of 10 minus x. Well, there's no division going on here, so we don't have to worry about dividing by zero, but we do have a radical, so we need to worry about whether or not we're going to take the square root of a negative. So the question here is, find the domain of this function. What are all the possible values of x that we are allowed to plug into this function, provided we don't make it do this? So, what's okay to plug in for x and what isn't? Interesting things, especially in a case when we're taking the square root of something. You should know that you can take the square root of any positive number. Can you take the square root of 0? Usually I hear mixed answers when I ask this question in class, and so I'm going to say that if you said yes, you can take the square root of 0, you are absolutely correct. And if you want to check that, pull out your calculator, take the square root of 0, and the answer is 0. So 0 is okay, but as soon as you plug in a negative number, that's when you can't do that, because you're going to be talking about imaginary numbers. So 0 is okay. Let's find out what x would make the square root, would make us take the square root of 0, because 0 is like the edge of what's okay. So if I look at the square root of 10 minus x, if I plug in a 10 for the x, I'm going to have 10 minus 10, which is 0, and then take the square root of that. So that is okay. So I know that 10 is okay. 10 is okay. Now, so that's going to be our dividing line. But then the question is, can I plug in something bigger than 10 or less than 10? So if I plug in, let's say I plug in a 9. If I plug in a 9 for x, that's 10 minus 9, that leaves 1. Can I take the square root of 1? Yes, I can. So a 9 was okay. Now let's plug in an 11 and see what happens. Going on the other side of 10. 10 minus 11 is negative 1, and then take the square root of that. Oh, we can't take the square root of a negative, so 11 is not okay. So what that means is everything from everything 10 and less, smaller, lower than, is okay. So the way we write this is, for these problems that ask about the domain, here's the format for your answer. The domain is left curly brace, x. This E-looking thing is a member of the set of, and then this funny R stands for real numbers. Here's what I was mentioning earlier. I know that in algebra they talk about imaginary numbers, which are the square roots of negative numbers, but we are only interested in real numbers. That's why these always start with x is a member of the set of real numbers, and a big vertical line, and so any restriction on x comes after this vertical line. So notice I just copied the same thing down in black several times because this part stays the same. So for this function, any real number as long as x can be 10 or anything less than 10. So as long as x is less than or equal to 10, then those are all the numbers that are fine to plug into that function. So, 21.5, same question, find the domain. Well, there are two things we can't do. We can't divide by 0, can't take the square root of a negative. This one here does not have a radical, so I don't have to worry about taking the square root of a negative. It does have a fraction line, though, and fraction line means dividing. So I have to make sure that I exclude anything that would make me divide by 0. But what do I have on the bottom here? I have x minus 2. What would make x minus 2 be 0? That's right, if I plug in an x of 2. Can I plug in into I can plug in anything larger than 2, because if I plug in anything larger than 2, then I have a positive number. If I plug in anything less than 2, I get a negative number, but that's fine as long as I don't end up with a 0. So x can be any real number as long as x is not 2. All right, 21.6. They changed the notation on us. Instead of saying f of x is this, g of x is this, they said y equals square root of x. Still the same concept. They just used a y instead of f of x, but it's still the same idea. And one of the reasons they did that is because they asked for the domain and the range. So let's tackle the domain first. We've got a radical, but no fraction line. So we have to worry about taking the square root of a negative. Well, it's just x, so that was nice and simple of them for us. We know that we can take the square root of 0, but nothing negative. So x can be 0 or anything greater than 0. But then the other question is, what's the range? Well, remember the inputs are the domain, and range is what are all the possible outputs. Another way to think of this is when you plug in x's and you get out y's, and when you graph a function, you can graph a function on the xy axis. So if I have my xy axis, and if you remember that, see, I was doing x in green, and I was doing y in red or purple, and so y is our vertical. I could also have said f of x, just to tie it back to the notation that we've learned a few minutes ago. And so the question is, the domain part asks which values of x can plug in. That corresponds to our horizontal possibilities. The range then is our vertical possibilities. And so, because the y is on the vertical scale. And so the example in the book says to graph this. Some of these are easier to see if they're graphed. Well, the graph of the square root function looks like this. It starts at 0, 0, and it starts going like this, and it continues on with an arrow forever that way. Kind of angling this way, not horizontal, but a little bit above that, kind of keeps going forever that way. Notice, if I'm looking on my x-axis, my horizontal scale, my graph can be 0 or anything to the right of that, anything that is greater than or equal to 0. So now let's take that same idea and apply it vertically. How far vertically does the graph go? Well, the graph doesn't go below the x-axis at all. It starts here, where y is 0, and it climbs up as far as our vertical movement. So our range is where y is a real number. Y can be any real number, and y is going to be greater than or equal to 0, because we're only talking about it going up. And so here we have the answer to this question. Our domain is x's, and range is your y's. Check it out. Remember I said earlier that this is our horizontal scale. What letter does that start with? H. And y is our vertical scale. It's really hard to write sideways. X, horizontal, input, domain. Y, vertical, output, range. A nice thing happens here. Alphabetically, X comes before Y. Alphabetically, horizontal comes before vertical. Alphabetically, input comes before output. It's just kind of nice how that all works together. Oh, and domain comes before range alphabetically. That's how I like to remember it. And so that is domain and range and how to find them. If you remember, key concept, these are the two things you can't do. You can't divide by 0. You can't take the square root of a negative. If it helps, you can also graph the function and see what happens there. The book does that on example 21.8. 21.8 has a square root on the top and then a fraction line with an x on the x minus 2 on the bottom. So because of the top part, the domain x can't be anything negative, so x has to be greater than or equal to 0. But then because of the bottom part, an x of 2 would cause division by 0. So for 21.8, my answer for that one, 21.8, because it's the square root of x over x minus 2, I have to say that my domain, x is a real number, x is, because of the square root part, x has to be greater than or equal to 0. But a 2 is also not allowed because that would cause division by 0. So I just have to also specify that x cannot equal 2. And then I can close off my curly braces. You can graph it and see the graph there. Anytime you have an asymptote, one of those vertical dotted lines where there is no y value at that value of x, those are numbers that you have to exclude from the domain. And that is that part.